All right, class. Dr. Blake Nelson. Welcome to this week's assignment. So this week we're going through linear programming, and maybe when you saw that to begin with, if any of you remember linear programming from algebra, you thought, oh no, not this. But the good thing is we're going to keep this pretty simple and hopefully show you how this can be used to optimize what you sell and what you produce. There's a method to the madness for sure, and you can put it in, and this can be very useful to an organization and a sales manager if they're understanding, okay, what's going to make us the most money based on the constraints we have and what we can sell or produce. So to get going on this one, I just gave you a problem here in Canvas we're going to go through. And the basics of it is we've got guitars and we've got violins that we're selling. Small little store. Those are our two things, and we want to maximize our profit. So the first thing you always want to do in Excel is just right here at the top, go maximize or minimize. Remember, that's one of the two. We can either maximize or minimize with linear programming. Then we'll just put in our formula, which is y equals 20 times g plus 40 times V. So in other words, the number of guitars we sell times 20, because that's our profit, plus the number of violins we sell times 40, which is our profit. Okay, so we always go down from here, just a couple lines, and however many variables we have here, that's how many cells we're going to go and drag upon, and we'll make them yellow. And what yellow is, yellow means these are the cells we're going to try to change to optimize our model. All right, so many of you remember earlier in the semester we had goal seek that we did to break even an analysis. What that did is it chose a certain cell, one cell, and optimized it or made it zero or a certain profit by changing the other cells. So we're going to do the same thing here. The difference is that we can do more than one cell here with linear programming. Remember, we're going to have as many yellow cells as we have variables. Okay, so then down here, we're just going to put the formula. And I always make this cell right here green. Just remember that's what I'm either maximizing or minimizing. And so this, we're going to put 20 bucks and then 40 bucks here. Those are our two variables. Make those dollar signs. And then here in this green cell, we don't put anything in these yellow cells. That's what we're going to try to change. But in our green cell, it's going to equal this formula. So it's 20 times, this yellow cell is going to be the units we produce for G or guitar, plus this 40 times our violin. So at the end of the day, we're trying to find out, this is our guitar cell, this is our violin cell, how many guitars we need to produce and how many violins we need to produce to maximize our profit in this problem. All right, so then we have to deal with these constraints. So let's come down here. We'll call this subject 2. All right, and let's go guitar. And violin, you could also just do G and V here, and then total. Come over here to a value. All right, so we've got 3 constraints we know about in this problem. When I look through it, we've got a constraint for machine A, machine B, and machine C. In other words, we only have 120 hours for machine A, 72 hours for machine B, and machine C, 10 hours. So for the value, just put that 120, 72, and 10. And I'll call this machine A, machine B, machine C. And we know that our total value that we have to use has to be less than or equal to 120, 72, and 10. So right here, I'm going to put less than or equal to, and then just drag that down. And we'll show you how we get that total here in a second. All right, so now let's fill out our constraints over here. Remember, these are our 3 constraints we can't go over. We know from the problem it tells us it takes us 4 hours and 2 hours to make a guitar. So that's 4 hours. Let me just make this all center. So we got 4 hours on machine A and 2 hours on machine B. For a violin, it tells us we need 6 hours on machine A, 6 hours on machine B, and then 1 hour on machine C. All right, so now one more formula here. This is going to equal our total here. Remember, we have to have less than or equal to 120 hours. So we take this total amount of hours for a guitar times, up here, remember these yellow cells are going to be how many guitars we produce eventually, and then plus how many hours it takes for a violin times how many violins we produce. So that is our formula. So this times this plus this times this, we're going to have a total here that has to be less than or equal to 120, meaning we can't go over 120 hours for machine A. Now the nice thing about this, we can just absolute value our two yellow cells, which is our B3 and C3, and then we can drag this down. So when we look at this, I'm going to click here. That doesn't matter because that's going to be nothing there. But then we've got our C3 times our C9, meaning we have to have the total amount of hours for machine C less than or equal to 10. And the thing is, it's just 1 hour here. So in other words, we know right from that we can't produce more than 10 violins. Sorry if I said guitars before. Violins is this column here. So there's no way we can produce more than 10 violins, because if we have a 10 here, this formula is going to be 10 here, and that's all it will allow it to go. All right, so now, just like that, we're set up and ready to solve this thing. Now, many of you aren't going to have Solver in your Excel yet, and you may have to Google how to add Solver to your whatever Excel you're using, whether that's 365 on a Mac or a PC. The way you'll know if it's there, it's data. Now 365 Solver is not always on the online version. It needs to be downloaded to your machine to get it. So then data, I have it here, I have Solver, but if you didn't, you would go File, Options, Add-ins, Excel add-ins go, and you can see I could click Solver here. I've seen other formulas where sometimes it's under this data tab where you can add it. So once again, just Google My Machine, whatever you're using, how to add Solver, and you'll find plenty of videos online how to do it if it's different than mine. Alright, so I hit OK, and so here we have Solver. One thing always to check right off the bat, make sure that this is checked. Make unconstrained variables non-negative. All that means is we can't use a negative number to maximize or go negative on one of these. That might not make sense right now, but just don't worry about it. All it means is we have to produce something. Okay, so make sure that's checked. The next thing, so we're just going to go right through it. So our objective cell that we want to do, remember we want to maximize, is always our green cell. And this one is a maximize. Always check that. I see that mistake more often than any other mistake with this, where you just miss this little thing where it's a maximize problem or a minimize problem. If it's min, you just switch it right here, max right over here. All right, and then by changing cells, I'm just going to come here and highlight these two. Those are the two cells that can change how many guitars we produce and how many violins we produce. And then subject to the constraints are things that have to happen. Remember, we have our 3 machines. And so there's 2 ways to do this. You click Add. You can do them one by one and just hit this has to be less than or equal to this. But since the sign is the same on all 3 of these, you can actually do them all at the same time. Now, if you had a less than or equal to, then a greater than or equal to, you definitely would have to do them one by one. But since they're all the same, you can do them all in a row. Always double check this. I see this mistake all the time, that you don't check whether it's less than or equal to or greater than or equal to. So I can just highlight right here that these 3 need to be less than or equal to these three. I'm going to hit add and then OK. Oops. Cancel. If I would have hit the other one, it would have just worked. So you can see now I have from D7 to D9 has to be less than or equal to from F7 to F9. And then if there was another one here, I could always delete it. I could change it if I'd messed up right here. Hit OK if it was not right for some reason. All right, so we have everything correct here. So I'm going to go ahead and I'm going to hit solve. And I'm going to hit OK. And so you can see my max profit is $640. Now the interesting thing here, right off the bat, is we would have thought, not knowing any better as a small business owner, that perhaps it was better to produce more violins because we're making double the profits. Well, the issue with that is they also take longer to make on the machines. And so we're only producing 4 violins is the best way to optimize profit, and then 24 guitars. And as you can tell, this is not a problem that would be easily done in your head. And many problems become much, much more complex with this, with many more constraints or even perhaps variables. For example, like if there was a third product to be plus, I don't know, 60 for every cello you sell, then you'd have another yellow cell here. The screen would be over 1, and it would be more complex because there's a third variable, and so on and so forth. So let's just kind of look at what happened here as well. Talking about utilization here for a second. So as you can see, our machine A, we are using with this max optimization model 640, all 120 hours of machine A, all 72 hours of machine B, but machine C, we're only using 4 of the 10 available. So we have a 40% utilization on machine C, and that is just fine, because what this did is it took all number and possibilities, and the absolute greatest way to make the most money in this scenario is to produce 24 units of guitars and 4 units of violins. Now, one thing I will say, if you made a mistake somewhere, sometimes with Solver, if something's wrong and it didn't work, you have to go through and hit it twice after the first time. The first time it's fine, but I've found that if there was a mistake, sometimes you have to go and hit it twice to get it to update. I see this formula that's messed up quite a bit, and then sometimes I see that this formula is messed up as well. And then obviously double check your sign, whether it's less than or greater than, and then also double check if you're doing a maximize or a minimize. So this is typically where I would end for the day, but I'm actually going to go and do you a favor and do a little bit more. So let's call this one String Store. And I'm going to open up this next tab. I'm going to call this Homework. I'm going to do the first problem of your homework for you, or with you, I guess, because you still have to do it. So the first problem of the homework is maximize is the objective function, and it's y equals 3x. We'll do 3a, sorry, 3a plus b. All right. And so, and then it also gives you the constraints down there, and I'll show you how to set those up here in just a second. And so once again, we've got the maximum 3a plus b. Okay. So let's set this up. We got our 2 yellow cells. We'll go right here. Go a little bit faster on this one since I just showed you how to do this. We got our green cell here. We got 3 for A. This one is what we're going to have for A, and then B is right here. Now, one thing to state here, that B, even though there's nothing there, we still know there's a hidden number there, which is a 1. Right? Not a 0, because it is a 1 that's hidden next to that B. All right, and then so this is going to equal, and you'll need to know that for the test as well. So this times this plus this times, okay, that disappeared on me, so that's C4. All right, and then constraints, it gives you the constraints on this one. I just wanted to show you how to do one that gives you everything that's not even a story problem. So constraints for A and B, total, and then value, 85, 18, and 4. Less than or equal to, just drag it on down. Then total is going to equal, we'll even throw in our constraints first. So we got 12, 3, 14, 2, and 1. So I just threw this in the exact same way from the numbers given. So now total is going to equal this times this plus this times this. I'm going to absolute value my yellow cell, so I can just drag it down. Just like so. All right. And so now we're looking at this, and Solver should stay there for you. I just showed you how to add it, or you can Google how to add it on your particular machine. And so I'm going to go to Data, and Solver's going to be here. So once again, I always first check, is this a max or a min? Well, objective cell first is always my green cell. This is a max again, not a min. Changing, I can always change my yellow cells, which is the number of units we produce for both A or B, or whatever these two yellow or more yellow cells are. All right, subject to the constraints, I'm going to add. There's a problem with this formula. Oh, I hit it twice. See that? Just here. Okay, just D5. Hit add. The total of this needs to be less than or equal to this. Hit OK. I double check my sign, and that is correct based on what they gave me in the problem. Hit OK. It's all there. I know I'm setting D5 to a max by changing these cells subject to these constraints. I hit solve, and I get an answer of 18. And in this one, I'm producing 6 units of A and 0 units of B. So as you can see, it's kind of interesting that the max is not even to use this third constraint, whatever it is. And I don't even tell you what it is. This is just learning how to do linear programming in Excel. But we're using all of constraint number 2, all 18 of the 18 is available, and then 72 of the 85 of this first constraint. And we get that answer of 18. So as I said, I just did that for you. That is the first problem on your homework, so you'll just need to go on and do the second one, which I also give you the objective function and start you out with the first constraint, so you can just fill it in from there. So this is linear programming. You can go back through this, obviously, and watch it again and again. I will keep these fairly simple for both the assignment and the exam, and straightforward with nothing trying to trick you. So good luck, and we'll talk to you soon.